Okay, here we are. So welcome back. This is part 3, and this is going to be tapping. So at this point, we've drilled the holes, both sides completely drilled out. We're going to change the bit, which I was going to do while I was taking a break, but I had to answer some phone calls. So we're going to remove the 17/32 bit. We're going to use the same concept of tightening it so we have absolute strength. And even with this, tightening this the way I do, it's still very well loosen up on you. So it's imperative that if you want to get it done, if you want to get in, get it done and get out, just get it done. Make sure you do it all correctly and get this thing tight. So here we go. I mean, I put some strength on that, so see how long it takes to come loose. So first thing we're going to do here in the tapping process is we're going to get started with a taper tap. Now this is like a cone shape, unlike the plug tap. There's another tap that we call a bottom tap, which I just got here for show. We do not use these bottom taps, period. Now, get one that you can see up close. Now this will be made sure that nobody, let's see, where is it? Okay, here we go. This right here is a bottom tap. And this bottom tap, as you can see on both sides, have threading that go all the way down to the last thread. And the danger in using one of these is it won't guide itself. And no jig plate, especially the one that I've discussed with you before. If this thing leans at all, and a jig will cause the every time a tap is put through a jig plate, it causes the jig plate to wear out. So give you an idea of how this works. After you get to about the 15th hole, this is what happens. So no matter how far down you take that, there you have it. So it might be tight in the beginning, but that's what happens. And so if you're using a bottom tap and you're accidentally putting too much pressure to one side or the other, it will literally cut that hole to the side. So you got to be real careful in knowing what taps to use. I'm not talking to you about this jig plate. I'm trying to discuss to you about this tap. So get this out of there. So here's your taps. So here's a bottom tap. This is an absolute mistake. You do not want to use one of these. And then what we use and what we recommend and how we're going to show you here is we have 2 taps. This tap here starts its cutting process in a cone. So it's basically nothing. It's the 1/2 inch hole or the 17/32 hole, and then it works its way up slowly, and so you have this long cone from about here to here, and that helps guide you directly straight. And the second tap is to get us the proper depth in the hole. And what we use, if you were to follow this with a flat surfaced bottom tap, this hole that you've started will not prevent you from cutting the walls with a bottom tap. So a plug tap is what's used in the next procedure. And what this does is it gets you down to the proper depth to get your head stud properly buried below the surface of the deck. So you don't, that's the idea. So there's just a few threads left here at the very bottom of the plug tap that allows you to stay guided by using this one. So there's 3 different kinds of taps, but we only use a coned and a plug. Set that aside, make sure it doesn't get mixed up. Alright, we're going to quickly get going here. We're going to use our ratcheting tap, which is a pretty unique tool. Get that nice and tight. A little dab of oil. Always use some kind of oil for cutting. Or just get this started. Don't grab your tap, no matter what kind of tap you're using. Don't grab it and hold it tight to one side. I usually let my fingers kind of loose and just for pulling back. And the reason I do that is because it'll guide itself. But if you put too much pressure to one side, you could easily cause it to start going sideways. But all you need to do is look at your tap. I'll look at it this direction here because it's a T shape, an upside down T. And I can look at that, and if it's out of whack at all, I can certainly tell instantly. And then look at it from this side of the block. You cannot see if you're leaning by looking over like that. A lot of people want to make that mistake. So I just quickly walk to this side. I can see that that's beautifully straight. That's beautifully straight. So another way to tell too is when you're going in, you go ahead and get started, you can feel the tap nice and loose. And that tells you it's going in straight. It's very difficult to get it off. Very difficult. So it just wants to just keep going on. Now I can drill all the way down like that if I want to, but I'm not gonna. I'm going to reverse this, pop that off, and I used my 1/4 inch or my 3/8 drive because it's the 3/8, and I'm going to slowly take that down. Now, if this was off, it would instantly show it in the drill. I'd stop and start over, but it's not, and it's going to easily go down. As you can see, do not take it to the bottom. That's not our goal. Getting it down quite a distance is where it still feels loose. If it starts to tighten up, you're done. Back it out. At that point, you definitely want to blow the chips out. Now, I'm going to go ahead and switch right now because I normally go all the way with that particular tap. I just want to use a taper tap like I did the drill bit, run through it. And then once I'm done with that, I can put it up in the drawer and then just begin with my taper or my plug tap. So I'm not even going to use this. At this point, you're already started. So just dip it a little bit, put it in the hole. You've already blown it out. Go ahead and get it started. Now, whether you're using a drill like I do, or if you're using a tap, this one here you're going to want to take down all the way to the bottom. It's a very quick operation. Until you know the actual depth of where this is going to come to a stop, go very slowly. Now there it is. I know that the bottom of where this tap stops right there in a 4.6 that's a pre-99, then that's where the tap's always going to come to. So what I like to do, and I use this to make it quick, and I'm very careful with it, and I've done thousands upon thousands of these holes, so that's why I can do it like this. I recommend that anybody else doing it, if you only done it the first time, make sure you use a tap wrench, don't use a drill. If you're a mechanic and would like to learn how to do this, be sure to do it on a block you could spare, because you could very easily break the tap off in the hole, and then it's a whole new ball game. So at this point, I'm going to back it out. I'm going to put it back in the forward direction. And I feel it, it touches, and I make sure I let go and let it stop on its own. Back it back out. Take it back down. The reason I do this, just try to assure that I've got a very clean cut hole. It makes it easier to install the stud. So we're just going to back it out. This is what I would normally do. A couple of times real fast. And then back it out. And that hole has been tapped. Done. At this point, that's been done. So if you could picture me running through with the taper tap very quickly, and then once that's done, I clean it up, and then I just quickly hand do that and use my drill, and I run through with the second one extremely fast, and it makes for a really quick drilling and tapping job. At this point, the hole needs to be nice and clean. This is where your stud's going to come in. I'm not going to put, I would normally put blue medium thread locker on this. I'm not going to. because I want to be able to take this back out so it's not in the way of my next hole. And so I just want to quickly go ahead and show you what we do. Now this right here is the alignment hole. So this is an important step. We grab a new fresh stud here. Set these here because I'm going to use them all in just a few minutes. Now I'm going to use something a little bit different here because I don't have any lubrication for my stud. But when you use medium thread locker, it is a liquid, so it kind of helps lubricate the process of putting the stud in. So you get the stud started, kind of helps you. You get down there. It may or may not get a little bit tight because you never know if there's a burr in the side of that hole, you know. So like right there it gets a little bit tight, but then it works its way past. Whatever was in there is a little tiny burr. So it is put in by hand if you can get it there. But it does not hurt to grab this thing with a pair of ice grips and work it down so you can get it down quickly. Now you're working with hardened steel, so it's not really a big deal. Now I have no thread locker in there, so it's not lubricated. This is just dry steel to dry aluminum friction going on here. So to give you an idea of what you can do and get away with, absolutely, man. Grab yourself a pair of pliers. This makes it real easy. Don't spend an entire day's work just installing your studs. You can't damage these heat treated. Now, this is a 4140 annealed steel, and they're individually heat treated to assure a perfect strength. So I just kind of like that right there, and then just kind of get the rest of the way in. The reason I got it angled is because normally there's studs standing next to it, so you want to be able to freely get it, and make sure that you're freely in there too. So at that point, we have a proper depth for each make and model. So let me grab a tape, show that to you. So what we have on these pre-99s is we want to be 4 inches above the block, and this gives us our proper depth. You can already see, I'm going to get you a really good close-up of this. There we go. Alright, bear with me because I'm trying not to cut this. I don't want to edit and cut this tape, so to give you a realistic look at this thing. Now, we're about 1/4 inch up, still too high. So we're going to go ahead and take it down a little bit. Eighth inch too high. I feel a little bit snug, but that is because the aluminum in there had a little bit rough on the walls, just might be slowing it down, and I don't have any kind of lubrication at all from the thread locker to give me anything to go on. But I like to spin it like this, just to know that it's in there and it's free, it's not tight or up against anything. But it's always good to be snug. You don't want it too loose in the hole. So with that in there, you can see it's spinnable. It's not set. You don't want to torque these. You never, in no application, you ever torque head studs in a block. So this has to set freely, and all the torquing is going to take place from this day forward on these hardened steel threads at the top. So at this point, we're at the proper depth. Now, when I look into the hole here, and I'm going to have to get you up close and personal with it for a second. Let's get you up here real quick. Sorry about that. Get a little dizzy being thrown around like that, huh? So, Let's pull you back a little bit. See if we can get up close and personal. Keep on the stand. Good view of this. Now this is the proper installation of a head stud. As you can see here, the threading on the stud right here is absolutely nowhere near. Look at this. Now I'm taking my knife down to the depth of the original alignment dowel hole. Has an edge around it to where your dowel stops, and so this threading is below that down inside there. So the proper depth for this particular motor has been achieved at this point in time. So as you can see, just wanted to make sure you can see that I can still go down to the depth of the alignment dowel. Now what this does is where the threads on this stud are pulling from in like a 45-degree angle is probably between these here. You're basically using the entire surface. So from where they're pulling is far out here past the point of where this one's going to be pulling from here. So what we're doing is we're maximizing the absolutely entire space by pulling from deep within the block. The farther we pull that stud up, the less clamping force, the less space we have. As you pull this up, the space that's being clamped comes closer and closer and closer to the stud. So once the threads have met the surface, you basically are pulling from just the circle around the stud. So it's imperative that in a head stud application, the head stud goes within the block. So this gives you an idea of how that is properly installed. Now we have created and designed the perfect alignment dowel to take the place of General Motors' original, and I'm going to show that to you. Let me get you backed up a little bit here so you get a better view of this, but still keep you up close there, right about there. So what we have is a pin that I designed, and you know, this is anybody could do this. This is an alignment dowel. So get you right here and let's just see this thing. This is the alignment dowel. Where am I at? Okay, there we go. This is the alignment dowel. This is the one that I designed to take the place of the original. It's a very nice heavy metal, and it is spring loaded. So what I've done, instead of having like the original, which is a solid steel ring, what we've done is we've cut this slot here in the side, and this slot right here causes it to be able to be spring loaded, but the type of steel that we use keeps it pressed out towards the outer edges. So it's really easy to install these. And let me grab the correct pair of pliers and I will show you. Bear with me. Any good pair of pliers will do the job. So all you basically have to do is go like this. Now, everybody knows how hard it is to pull these out when it's the original. So although this stud is coming back out so we can complete the project, I want to show you the alignment base stud, how it goes back into the block for the proper engineering to be achieved once again. But at the same time, if you ever need to pull it out, it's very easy to pull out. So what I do is grab it here, spring loaded now, get a little bit towards the bottom, pull it together, get it started, just like that. It's already started to go in. So at that point, I'll pull the pliers up and put them on top of it and let it sit there, kind of slide. I can use my hammer to see that. Very quickly I was able to slide that down, and it's got full pressure up against the side. So we have a perfect alignment to take the place of the original. So it's basically, it's identical in engineering. It's got the same concept on deck space for use for clamping force. Same concept for using a pin, alignment pin to put back in, except this one here is more of a racing application, so it's removable. So at that point you just squeeze a little bit and pull it right back off, and you have the same pin ready to go, so when we're ready to do it. So we'll take that off, and we'll go ahead and pull this stud back out, and we'll get started with the rest of them and get this block flipped upside down so we can get started. Remember, I don't have any lubrication on this stud, so it's a little squeaky. No big deal, that's normal. Pull it back out of there. That'll give you kind of an idea and a concept of the depth of the stud. We'll put this barrel pin on top of it for you. So this was buried in the block, and it was down, you know, about like this here. I think it's about like a little bit more, maybe about like that. You can see that when I'm not holding the right spot, and I apologize. Let's get you back a little ways. There we go. Pull you back. Sorry for this camera use again, but it was imperative that I did this without editing it, according to the people who had questions for me and was wondering if it was true and real. So here's the stud, here's the alignment pin. It drops over the top, and then it squeezes down into the block. So it's approximately about like this here. Once it's in place, this is approximately on the pre-99s is just about like that. So if you could imagine the amount sticking up out of the block, this is about where my thumbnail is right there, and then pull that off of there and imagine that being about right there. So the space that we have between the threads and here maximizes that clamping force. So this is one of our studs here. This is our barrel pin, and that's how they are installed, and very quickly and very fast. Anyhow, let me get you sit back over here. Make sure you're high enough. I hope that answered your questions. I know it seems kind of unrealistic to see me using a drill when it comes to tapping, but like I said again, I don't recommend that for the DIY guy unless you've learned how to do it ahead of time. I do recommend it for people like my buddy Scott up north in Roseville, and to learn that concept to make it happen real quick. There you have it. A quick drilling process, a very quick second drilling process, a very quick taper tap installation, or a tapping for installation because of its guide, because of its cone shape, followed then by a plug tap that gets you down to the proper depth that your stud is required to go, and then your stud itself, and then to be able to put that in with ease and get it to the proper depth by using a tape measure and the instructions that we supply with each one, with each set. Make sure you have the proper depth by measuring the outer part of your stud, and once you're down to that point, you can freely install all 4 of your dowels and get those in place. And at that point, clean her up. Unless you got more to do to the engine, your head studs are ready to go, and get it back together. Now, I'm going to go ahead and get this block finished tapped, and I will get it flipped upside down, get it apart, get it resealed and cleaned up, ready for heads. And then I'll go ahead and I'll pick up at that time and show you how heads slip on, and what to do if you feel like they're a bit tight going on, and the simplicity of making it go on rather easy. So I hope you enjoyed this video tutorial as much as I have enjoyed showing it to you, and let's move forward. Get her done, huh? Thank you.